In the beginning, approximately 13.6 billion years ago, our Milky Way Galaxy began its journey through the cosmos. Born from the gravitational collapse of a massive cloud of gas and dust just a few 100 million years after the Big Bang itself. This ancient spiral of stars we call home stretches across an incomprehensible 100,000 to 180,000 light years in diameter, a cosmic island floating in the vast ocean of space. Within this magnificent structure lies our solar system, positioned in a quiet neighborhood about 26,000 to 28,000 light years from the galactic center, nestled in what astronomers call the Orion Arm, or Orion Spur. If you could somehow travel at the speed of light, it would take you 26,000 years just to reach the heart of our galaxy from Earth. The Milky Way is not just vast in space, but also in substance, containing an estimated 100 to 400 billion stars, each one a sun with its own story to tell. Among these countless stellar lights, scientists believe there may be as many as 100 billion planets, suggesting that our cosmic neighborhood is far from empty. Our galaxy spins through space like a cosmic carousel, with our solar system orbiting the galactic center at an incredible speed of approximately 515,000 miles per hour, 828,000 kilometers per hour. Yet despite this tremendous velocity, it takes our sun about 225 to 250 million years to complete just one orbit around the galaxy's center, a period astronomers call a galactic year, or cosmic year. The total mass of our galactic home is truly staggering, weighing in at approximately 1.5 trillion times the mass of our sun, though most of this mass remains invisible to our eyes. Hidden in the mysterious dark matter that pervades the galaxy, the Milky Way reveals itself as a barred spiral galaxy, a cosmic pinwheel with graceful arms spiraling outward from a central bar-shaped structure of stars. This bar stretches approximately 27,000 light years across the galactic center, acting as a stellar highway that funnels gas and dust toward the core, triggering waves of star formation. From this central bar, 4 major spiral arms sweep outward through space: the Perseus arm, the Norma arm, the Scutum Centaurus arm, and the Sagittarius arm. These arms are not solid structures, but rather density waves, regions where stars, gas, and dust congregate like traffic, slowing on a cosmic highway. At the very heart of our galaxy, in a region called Sagittarius A star, lies a supermassive black hole with a mass approximately 4 million times that of our sun. This gravitational monster sits relatively quiet now, but it anchors the entire galaxy, holding billions of stars in their orbital dance. The galaxy isn't flat like a dinner plate, but rather has a disk that's about 1,000 light years thick on average, though it bulges to several thousand light years at the center. Surrounding this disk is a roughly spherical galactic halo that extends outward for about 200,000 light years, containing ancient globular clusters and mysterious dark matter. Within the disk, the Milky Way is divided into distinct populations of stars. The thin disk contains younger stars, including our sun, along with gas and dust where new stars are still being born. The thick disk holds older stars that orbit with different characteristics, while the central bulge is densely packed with ancient stars, many over 10 billion years old. Our galaxy is not alone in its neighborhood. It's accompanied by more than 50 satellite galaxies, including the famous large and small Magellanic Clouds, visible from the southern hemisphere. these smaller galaxies orbit the Milky Way like moths around a flame, slowly being consumed by our galaxy's gravity. The disk of the Milky Way contains vast amounts of interstellar medium. Approximately 10 to 15% of the galaxy's visible mass consists of gas and dust floating between the stars. This material is the raw ingredient for future generations of stars, the cosmic recycling program that has continued for billions of years. Astronomers have discovered that the Milky Way has a warped disk, not perfectly flat, but twisted like the brim of a hat. This warping may be caused by the gravitational influence of our satellite galaxies, or the result of ancient collisions with smaller galaxies. The galaxy's spiral arms are illuminated by HRI regions, vast clouds of ionized hydrogen gas where massive young stars are being born. These stellar nurseries glow with a distinctive pink-red color and can span hundreds of light years across. From our vantage point on Earth, the Milky Way appears as a luminous band stretching across the night sky, containing approximately 200 to 400 billion stars when viewed from a dark location, far from light pollution. This glowing river of light has inspired countless myths and legends throughout human history. The Milky Way is not a static structure, frozen in time, but a living, breathing entity, constantly creating new stars. Our galaxy produces approximately 1 to 2 new stars every year, though this rate has slowed considerably from the galaxy's youth, when star formation was far more vigorous. These newborn stars emerge from vast molecular clouds, the largest of which can contain millions of times the mass of our Sun. The most massive of these clouds spans over 600 light-years across and contains enough material to create millions of stars. The galaxy experiences periods of intense activity called starbursts, often triggered when the Milky Way consumes smaller galaxies, or when density waves compress gas clouds in the spiral arms. During these events, star formation can increase dramatically for millions of years. Not all stars in the Milky Way orbit peacefully in the same direction. There are high-velocity stars that move at speeds exceeding 500 kilometers per second relative to the average motion of stars, sometimes even fast enough to escape the galaxy entirely. These stellar wanderers may have been ejected by close encounters with the central black hole or by supernova explosions. The Milky Way's supermassive black hole, Sagittarius A star, occasionally feeds on nearby material, creating brilliant flares of X-ray and radio emissions that astronomers can detect. Though it's relatively quiet now, evidence suggests it was much more active in the past, possibly acting as a quasar that outshone the entire galaxy. Throughout the galaxy, massive stars end their lives in spectacular supernova explosions, with approximately 1 to 3 supernova occurring per century in the Milky Way. These cosmic detonations scatter heavy elements throughout space, enriching the interstellar medium with the building blocks of planets and life. The galaxy is threaded with magnetic fields that pervade the interstellar medium, influencing the motion of charged particles and the formation of stars. These fields are approximately 6 microgauss in strength near the Sun, thousands of times weaker than Earth's magnetic field, but significant across galactic scales. Astronomers have discovered stellar streams, long ribbons of stars stretching across the galactic halo. These streams are the torn remnants of smaller galaxies and globular clusters that have been shredded by the Milky Way's gravity, like cosmic taffy, pulled apart by tidal forces. The galaxy rotates differentially, meaning the inner regions complete their orbits faster than the outer regions. This differential rotation causes the spiral arms to wind up over time, though density wave theory explains how they maintain their structure despite this winding. Deep within molecular clouds, astronomers have detected over 200 different types of molecules, including complex organic compounds like amino acids and sugars. These discoveries suggest that the basic chemistry of life is common throughout our galaxy, floating in the space between the stars. The Milky Way's history is written in the scars of ancient collisions. Approximately 10 billion years ago, our galaxy merged with a substantial dwarf galaxy that astronomers have named Gaia Enceladus. This collision added billions of stars to the Milky Way's halo and fundamentally reshaped our galaxy's structure. Evidence of this ancient merger appears in the unusual orbits of certain stars and the chemical composition of stellar populations. The collision was so significant that it may have triggered a period of intense star formation, creating many of the stars we see in the galactic halo today. But the Milky Way story of cosmic collisions is far from over. Our galaxy is currently in the process of consuming the Sagittarius dwarf elliptical galaxy, a small galaxy that has already passed through the Milky Way's disk several times. With each passage, the Milky Way strips away more stars, slowly absorbing this smaller companion. The Large and Small Magellanic Clouds, our two most prominent satellite galaxies, are also on a collision course with the Milky Way. In approximately 2 to 4 billion years, these galaxies will merge with our own, adding their billions of stars to the Milky Way's collection and potentially triggering new waves of star formation. But the most dramatic event in our galaxy's future is yet to come. The Milky Way and the Andromeda Galaxy are rushing toward each other at approximately 110 kilometers per second, about 250,000 miles per hour. In roughly 4.5 billion years, these two giant spirals will collide in a cosmic dance that will last for billions of years. This collision, while sounding catastrophic, will be surprisingly gentle for individual stars. The vast distances between stars mean that actual stellar collisions will be extremely rare. Instead, the two galaxies will pass through each other, with gravity pulling and stretching both galaxies into new shapes. Computer simulations suggest that the merger will eventually create a single giant elliptical galaxy, which astronomers have playfully nicknamed Milkomeda or Milkdromeda. This new galaxy will be larger than either of its parent galaxies, containing the combined stars of both the Milky Way and Andromeda. During the merger, the supermassive black holes at the centers of both galaxies will spiral toward each other, eventually merging into a single, even more massive black hole with a mass exceeding 50 million times that of our Sun. This merger will release tremendous amounts of energy in the form of gravitational waves. Our Sun and solar system will likely survive this galactic collision intact, though we may be flung into a different region of the merged galaxy, possibly even into the outer halo. The night sky will look dramatically different, with the combined stars of both galaxies visible overhead. By the time this merger is complete, approximately 7 billion years from now, our Sun will be entering the final stages of its life, expanding into a red giant. The galaxy's transformation and our star's death will occur on similar cosmic timescales, marking the end of an era for both our solar system and our galactic home. Despite centuries of observation, the Milky Way still holds profound mysteries. The most perplexing is the nature of dark matter, which makes up approximately 85 to 90% of the galaxy's total mass, yet remains completely invisible to our telescopes. We know it exists only through its gravitational effects on visible matter. This invisible dark matter forms a massive dark matter halo that extends far beyond the visible disk of the galaxy, possibly reaching out to 600,000 light-years or more from the galactic center. This halo shapes the galaxy's rotation and prevents it from flying apart as it spins. At the galactic center surrounding Sagittarius, a star, astronomers have discovered a cluster of massive stars orbiting at incredible speeds. Some of these stars complete orbits in as little as 11 to 16 years, reaching speeds up to 5,000 kilometers per second, nearly 2% the speed of light, as they whip around the supermassive black hole. The Milky Way contains approximately 150 globular clusters, ancient spherical collections of stars that orbit in the galactic halo. These clusters are among the oldest objects in the galaxy, with ages reaching 12 to 13 billion years, nearly as old as the universe itself. Astronomers have discovered that the Milky Way has a Fermi bubble, two enormous lobes of high-energy gamma rays extending 25,000 light-years above and below the galactic center. These bubbles may be the remnants of a massive burst of star formation, or a period of intense activity from the central black hole millions of years ago. The galaxy's disk contains vast cavities and superbubbles blown out by the combined effects of multiple supernova explosions and powerful stellar winds from massive stars. The largest of these structures can span hundreds of light-years across, creating holes in the interstellar medium. Mysterious hypervelocity stars have been detected racing through the galaxy at speeds exceeding 1,000 kilometers per second, fast enough to escape the Milky Way's gravitational pull entirely. These stellar speedsters may have been ejected by interactions with the central black hole, or by the explosion of a companion star. The Milky Way is part of the Local Group, a collection of more than 50 galaxies spanning about 10 million light-years. Beyond the Local Group, our galaxy is part of the even larger Virgo supercluster, containing thousands of galaxies, and ultimately the Laniakea supercluster, which encompasses 100,000 galaxies, including our own. Recent observations have revealed that the Milky Way may have a thick disk of stars that form differently from the main thin disk. This thick disk contains older stars with different chemical compositions and orbital characteristics, suggesting a complex formation history involving multiple episodes of star formation and galaxy mergers. The center of our galaxy is shrouded in dense clouds of gas and dust that block visible light, which is why we can't see the galactic core directly with optical telescopes. However, infrared, radio, and X-ray observations can penetrate this veil, revealing the intense activity hidden at the galaxy's heart. Finally, the Milky Way is a reminder of our cosmic perspective. Every star you can see with your naked eye in the night sky, all 4,000 to 5,000 visible stars, are part of our local neighborhood, within just a few thousand light-years of Earth. the vast majority of the galaxies, hundreds of billions of stars, remain forever invisible to our unaided eyes. A humbling reminder of both the galaxy's immensity and our small but precious place within it.